Hi class, this is a video with minimize. This is the big M in 6-4, but it's such a long regular video that I'm kind of separating off some of those questions. So this is straight from the note packet. It's example 4, and you're minimizing, which I don't think I wrote up here, but we'll just write min up here. So to minimize with the big M method, we have to take and we know that T or C or whatever is equal to negative P. So what we do is we switch our objective function and we maximize. So when we go to do our constraints, if any of them are going the wrong way for a max, so if we have any greater than, those are the ones that will add our negative slack and our artificial variable to. Okay, so we're still solving a min with max, but we basically switch our signs on our objective function, which we'll do at the very beginning. So right now it's minimize. So what we'll do is we're going to maximize, think of it as negative p. So that would become 2x1 plus x2 instead of the negative 2x1 and the negative x2. So we're switching those signs. This equals t. That's what they use. I always use cost, but cost and p to the two, but we'll just use the t that they show in the note packet, which is fine. And then from here, the one that is going the wrong direction here on us is this one. And what's wrong is a maximize always has less than. If the constraint goes greater, then we'll have to use the big M method. Okay, so when I go to set these up, the top one is x1 plus x2, and then we'll add in our slack variable equals 28. So that one's our traditional, it's less than. So we just add in that slack variable, okay, and change it to equal. Now this next one, we're going to have to write it as 5x1 plus 3x2, and we're going to have to write it as a negative slack 2 and add in our artificial variable. Okay, so we're going to add those both in, and then anytime we have something go in the wrong direction and we bring in the artificial, then we need to go up here and maybe I'll do this in red, minus the big M A1 off of that section. So it should be after that 2x plus x2. So from here to write this part right here, excuse me, where'd they go? This part right here, to write that, everything has to be over here with the P. Okay. Or the T, sorry, we want it to be a T. So over there with the T. So when I rewrite that function, be careful, it's going to become a negative, let me see here, negative 2x1 minus x2, and then it becomes a plus big M A1, which we write in the A1 row, or the A1 row there, yeah, plus our T equals 0. So that's kind of how we set up those slack variables. So you're still switching your signs, and then so all three of these changed their signs, and then they go over with the T. Okay, so if I write this as our initial tableau, or we can call it just our initial matrix. We have x1, we have x2, we have slack 1, we have slack 2, we have a1, and we have t. Those are all of our variables. Excuse me, you have to label them because you could put a1 before s. So the process will work out the right answer regardless of which area you put them. So we're going to fill this in. So this one will go 1, 1, 1, 0, 0, 0, 28. Okay, and then this one will go 5, 3, none of them here, but a negative 1 here and a 1 here, a 0 and a 105. Okay, then we have our negative 2, negative 1, 0, 0, 0, M, 1, 0. Okay, so that's our initial setup. From here, everything else stays the same. I'm still going to finish the problem. If you're understanding how to finish, great, you can stop the video, but it might be helpful to watch it all the way through and or pause, try the step, see if you get it right. It's also a good way to make sure you're learning it. So what do we do first? We move M, right? So we're going to take and times this row here by a negative M so that we can add it to this M. It kind of puts the M's all in there, right? M's just a big number. That's what it stands for, big M, big number. So we're going to take negative M and we're going to times it by row 2 and then add it to row 3 and replace it on row 3. And I should see all of those steps on your exams. Okay, just like I'm writing. All right, so just 5 times negative M is negative 5. So this is negative 5M minus 2, right? Because you take negative M times 5, negative 5M minus 2. So similar to this one, and I'm going to get negative 3M minus 1, and then I get a 0. Negative, this one ends up just being M, this one's 0, this one's 1, and this one's negative 105M. Okay. If I go too fast, pause the video, write them out, make sure you got followed those steps, okay? Everything else stays the same. Okay, got it all written out. There we are. So now we have moved the M's in. So which one is the bigger M? Negative 5 times a huge number or negative 3 times a huge number? Which one makes a bigger number? Negative 5. So then this would be our biggest negative in the bottom. So above it, we have a 5 and a 1. So 105 divided by 5 is 20. I think I have 20. I think I have 21 in my notes over here. Yeah, 21. I just wrote it so small I couldn't tell. And then 28 divided by 1 is 28. So 21 is the smallest. Same thing we've been doing. They meet, that's our pivot. Make your pivot a 1. So row 2 divided by 5. So I'm going to take that row and divide it by 5. So this row stays the same. Leave yourself more space as you write these down because the M's at the bottom are kind of tricky. So this becomes 1. This becomes 3/5. This becomes 0. Negative 1/5. 1/5. 0. 21. I prefer just to divide them all by 5 and use the fractions. And then I'll just use the fraction key on my calculator if I get stumped. That I think that's easier when you divide by 5 than to put it in your calculator and get the decimals. But decimals are fine. Okay, bottom row stays the same. Okay. There we are. Now this is our pivot. Oops, keep it circled. So we're going to times by the pivot row, add to the other rows to make 0. So negative 1 times row 2, add that to row 1, and I replace it on row 1. That would give me the 0 on the top of our pivot. Below it, what would I use? Well, I'd use the opposite of what I see, which is 5M plus 2, because 5M plus 2 plus negative 5M minus 2 would make a 0. Opposite signs, you times this by the pivot row, add it to the row we want, replace it on that row we want. All right, let's now do that step. So I'm going to just imagine these all negative and add them up here. So I'm imagining them negative and adding them up there. Okay, so this top one is going to be 0. Negative 3/5 plus 1 would be 2/5. 0 times anything plus 1 is 1. Negative 1/5 times A negative is a positive plus 0. Negative 1/5, that one's a negative 1/5, and then that one's a 0. Negative 21 and 28 make 7. Okay, the bottom row is a little more tricky. So I am going to write over here just to show you kind of how that works. But we're taking, for this first one, it's a 0. Okay, because it's pretty easy to see that the 5m plus 2 minus the other one is going to give us 0. But then this next one, I take 3/5 and I times it by 5m plus 2, and then I minus 3m minus 1, because I'm adding those together. You could write it as add and then plus the negative 3m minus 1, however you want to think of that. But basically, this times this plus this. I wrote it out so I could figure it out. So negative 3/5 times 5, the 5's cancel. It's going to be 3m. 3/5 times 2 would be 6/5. So plus 6/5 minus the 3m minus 1. Well, these are easy. They cancel. Sweet. 6/5 minus 1 is 1/5, because 5 of them make a whole, and you had 1 extra. So this ends up being 1/5. All that work for that. And the next one ends up being a 0. And then I have to do the next one because I can't do that one very well in my head either. Negative 1/5 times 5m plus 2. And then you add it to m. Well, this one times this one gives me just negative m. This one times this one is negative 2/5 plus m. So m's are gone, and darn it, I have a negative in the bottom row. I was really hoping we wouldn't have a negative anymore. One pivot and done would be delightful, but we do. So we're over 1, 2, 3, 4. So now we're on the 1/5. I'm kind of running out of room, so I'll do it down here. We have 1/5 times 5m plus 2, and then we add it to 0 for our next one. So this becomes just m plus 2/5. So this is just m plus 2/5. Okay, and then this one's a 1, thank goodness. And this last one is 21 times 5m plus 2, and then we minus the 105m from it. So this is 105m plus 42, excuse me, and then minus the 105m. Those cancel. Your m better cancel off that last row, because we don't want an answer with an m. M stands for a big number. We want an actual profit or cost or whatever it is. So this ends up being just 42. Okay, I'm going to magically take this work and move it out of my way up where, I don't know, it's just going to be ugly way up there, out of my way. So then from here, we need to write in that middle row. That one, 1 3/5, 0, negative 1/5, 1/5, 0, 21. Okay, here's where we're at now. And then our next thing would be, okay, where's the next pivot? Well, here's our negative, and we cannot use this row, right? Because it has a negative 1/5 in that spot. So the only spot I could use as my pivot is here. Can't use a negative or a 0. Okay, if that 1/5 would have been negative also, we just would have no optimal solution. Okay, so that one we need to times by 5. So take row 1 and times it by 5 so that that makes that a 1. Okay, because that's going to become 0, 2, 5, 1, negative 1, 0, 35. Okay, everything else stays the same. Okay, so here, and this was our pivot here. Okay, so now we're going to have to times that pivot row by 1/5 and by 2/5 and add to those respective rows. So 1/5 times row 1, add that to row 2, replace that on row 2, and then 2/5 opposite sign times your pivot row plus the row that you want the 0 in, replace on the row you want the 0 in. Okay, let's do that. So 1/5 times the top row and then plus the middle row there. So 1/5 times 0 plus 1 is going to give me 1. Okay, 1/5 times 2 is 2/5. 2/5 plus 3/5 is 5/5 or 1. Okay, this one, okay, 5 times 1/5 is 1. 1 plus 0 is 1. Did I do that one wrong? I'm feeling like I did that one. Hold on, let me think through that one again. I was like, wait, 1/5 times that is 1 plus 1, 2, 3. How did I get the 1/5? I don't know. I'm gonna keep going. I don't have the same answer on my key, but I agree with my 1, so I'm gonna keep moving. So 1/5 times 1/5 plus this one is 0. 1/5 times this one is negative 1/5 plus 1/5 is another 0. And then the last one, 0 times anything is 0 plus 0 is 0. And then 35 times 1/5 is 7. 7 plus 21 is 28. Okay. Then the bottom row is going to be 2/5 times that top row plus the bottom row. So 0 times that plus 0 is still a 0. 2/5 times 2 is 4/5 plus 1/5. That ends up being a 1 also. Because 4/5 plus 1/5 is 5/5. Okay, then this one would be 0 times anything plus 0. Oops, nope, it's 5. Just kidding. Did the wrong row. 5 times 2/5 is 2 plus 0 is 2. 5 times 2/5 is 2 plus 0 is 2. Totally don't have that answer there because I didn't get that other answer in the one spot. Okay, then this one will be 2/5 time. Oh, I'm adding it. Yeah, no, I added it to this 2/5. 1 times 2/5 is 2/5 plus the 2/5 is 0. Should better be because that's what we set it up for. 1, 2, 3, 4. I don't know where I got that. Okay. All right. So 2/5 times row 1 is negative 2/5 plus this one. So write that one out. It's like negative 2/5 plus m plus 2/5. So the 2/5 cancel and I just have the m left for that one. This one's a 1. 35. Okay, so 35 times 2/5 is going to be 14. So 14 plus 42 is 56. Here. And then that top row is a 0, a 2, a 1, a 1, a negative 1, a 0, and a 35. And we're done. We have no more negatives in the denominator. I'm not sure why 2 of my numbers are off from my key. That just means I did it wrong today in class or just now. Maybe I made a mistake somewhere. I hope not. Okay, so from here, what's our solutions? Well, this was x1, this is x2, this is s1, this is s2, this was our artificial variable, and this was our t variable. So we're going to go back and say x1, go over, and that's 28. x2 is what if we have numbers in x2? It's 0. But one of our slack variables actually has meaning. So our slack 1 is still 0, but our slack 2 is actually 35. So whatever meaning that slack had, it actually has a number. Like we didn't use whatever that is. Artificial variable never comes out to be anything because it shouldn't. And then our t is 56. So if our t is 56, if we go back to our original, then p is equal to negative 56. And that's the one we're looking for. So you have to switch that sign at the end. Okay, that's a minimized problem done with simplex. And I'm sure the same thing happens to you as it does me. You do one little multiplication or add wrong, or you lose a negative, or in your head you think 1/5 plus 1/5 is somehow, something that's not 2/5, that's where the errors come in, and it does make these hard. All right, so that's the best I can do on showing you how to do that. Let me know if you have any questions.